All right, hello and welcome back. And in today's video, we are going to be discussing techniques of integration, part number one. So, this technique is reverse chain rule. All right, and we're going to go on a deep dive, and I'm going to help you understand how to use reverse chain rule. And before I start, just note reverse chain rule is very similar to u-sub and follows the exact same method and can be applied in the exact same cases. But reverse chain rule is a bit more rigorous and it makes a bit more sense than just multiplying by differentials, which isn't exactly something you could do, rigorously or with proof, but it does work, right? But I'm going to be using reverse chain rule because I think it's a bit better. And your class might also be using reverse chain rule, so that's another reason. So let's start. We may wish to create rules for integration by rewriting our rules of differentiation, or sorry, reversing, right? Such as product rule and chain rule, etc. So that's our, topic, what we're going to be going into this theme, right? That in order to figure out techniques of integration, which is anti-differentiation, we're going to take our rules we already know, chain rule, product rule, maybe quotient rule, reciprocal, I don't know, and we're going to reverse it and go the opposite way. That way, if we identify some sort of product rule, we see, oh yeah, I know how to do this. This is easy. This is just chain rule, or this is just product rule in reverse. And in this video, I'm going to be doing reverse chain rule. So we're going to recall what chain rule is. So I'm going to zoom in for this. Hopefully you can see the derivative of a composition f of g of x is f prime of g of x times g prime of x, right? So if we wanted to take this antiderivative, right, f prime of g of x times g prime of x, we can just get our original function plus c, obviously, but I don't think I have to show that. There's always an implied plus c, right? But we may not always see f prime in our heads, right? This requires seeing f prime of g of x, which is pretty hard to see, how are we going to know which one's f prime? And we would have to identify f. So we could just see that f is an antiderivative of f prime. So we'll just replace f prime with f. And where we see f of x in this function right here, we'll replace with the antiderivative of f. So I'll show you what that looks like, all right? If we want to differentiate the capital F of u of x, right, which is we're replacing f with capital F, right, we're going to get capital F prime of x composed with u of x times u prime of x, which is just lowercase f of x composed with u of x times u prime of x. So we can apply that idea. Hopefully now, instead of just having a g prime, we can have a g. And hopefully I'll show you with reverse chain rule. So this is the theorem. This is the statement, okay? The antiderivative of g of u of x times u prime of x dx is the integral of g of x dx composed with u of x. So whatever we get for the integral, we're going to compose that with u of x, right? And hopefully you are really proficient with compositions and derivatives. You need to be for this, all right? Otherwise, it's not going to work out. So notice crucially, we have g of u, right, and u prime. The main thing, g of x can be anything. The main thing you have to notice is our u and our u prime. Those are the big things, right, that show up that you need to know, all right? So we're going to prove it, and the proof is literally one line. Okay, we just differentiate the right side, and as I already showed you, you just get the integrand, okay? So if by choosing some g of x and some u of x, we can get some function f of x to be equal to g of u of x times u prime of x, right? But we have to manipulate and choose, okay? Then we can use reverse chain rule. So that's our format. You need to know it, okay? And always remember u prime needs to be on the numerator or same thing as being multiplied. So here's an example. It's a basic one, linear substitution. All right. It's the integral of g of mx plus b dx. So obviously g of x is just that is composed with mx plus b dx, right? And we want to get, all right, you notice kind of our inner function should be u of x. U prime of x is m, right? So we want to multiply by m, but in this case, since m is a constant, we might choose to do that by multiplying 1 over m outside and m inside. This only works again because m is constant, right? Otherwise, we can't do this. Then, of course, we just use our reverse chain rule and we get this. So we just replace mx plus b with u of x. We have g of u times u prime. and we use reverse chain rule to compose u of x with the antiderivative of g, 1 over m times the antiderivative of g of x dx composed with mx plus b. All right, now our next example I'm going to show you is a linear substitution of sine of x, okay? So we're going to choose g of x to be sine of x, that's our outer function. U of x is our inner function, 3x minus 1, and we need u prime 3 to show up somewhere. So we want to have 3 somewhere here, okay? But in order to do that, and in order for this to be equal to that, we need to have a 1 over 3. All right, so you should hopefully see these two are equal now. They balance each other out. So we're going to now write that 3 is u prime of x. We're going to write sine of x is our g of x, composed with 3x minus 1 is our u of x. And now it should be obvious we can use reverse chain rule to get the antiderivative of g of x dx, right? Composed with u of x, which is just equal to 1 over 3 times, what is the antiderivative of sine of x? It's negative cosine of x, composed with u of x is 3x minus 1. And of course, never forget to add the c once you integrate. So here's another example, and I'll work you through it. So first, we're going to, what are we going to notice? Well, hmm, I'm thinking here, well, on the inside, I'm looking for u of x. That's the first thing. So we have this inside function. I like that, okay? And the derivative is easy. It's just 8x. And we already have an x here, so we're only off by a constant. That is perfect, okay? We're going to multiply 1 over 8 to get 8x. So we need that 8 here. Perfect. Right here we have 8x is our u prime. And here we have our u of x. So what is our g of x? Well, it's just whatever this is, right? It's just 1 over the square root of u of x. Instead of u of x, just place x. So that's our g of x, 1 over the square root of x. And in this case, we can hopefully differentiate, and you can see why this whole thing works, right? So the key thing, finding our u and our g. I'm going to take some time now to discuss some tips before we head on into this, okay? Step 1, you want to try to identify a u and u prime in your head. You should be thinking, okay, well, what could be my possible opportunities for u and inner function? And if that I do choose that, what is u prime? Does it work? If you can't, right, get a u, either, reverse chain rule just doesn't work and you need to try something else, or you can try to algebraically manipulate, okay? You can try to do some algebra, move some stuff around. If you need to, anywhere you have an x, right, and it doesn't belong to the derivative of u, you can just replace x as a function of u of x, right? Let's say you have u of x is equal to 3x plus 1. Well, then wherever you see an x, obviously only when you need to, you could just replace that with u of x minus 1 over 3, and then, do some algebra, and you get or your g of x, right? And I'll explore some examples of how that might show up. And of course, finally, once you're done, you should just finish integrating. So here, what are we going to notice? Well, one option for u is this, and I like that because this u of x gives us our derivative we want. Why? So we're going to ignore this. This power to the power of 4 is our g of x, right? We'll get to that later. First, we choose the u of x, we differentiate. Oh, yeah, we have our u prime here. So that is the same thing as saying u prime of x times u to the fourth of x dx. But wait, u to the fourth of x. Well, that's just the same thing as saying x to the fourth composed with u of x. Right? We want to express it like this. So that means our g of x is x to the fourth. And now we can just use reverse chain rule. We get is the antiderivative of x to the fourth dx composed with u, which is 4x minus that. Hopefully you know your reverse power rule. I covered it in the previous video, 4x. And you should hopefully be able to compose that and finish that. That's not the hard part. The next problem we're going to work through, and you should be very familiar with power rule, right? That should be easy. What could be our u? So this could be our u, but that's not really helpful. I think this is a better candidate for u, so we'll try that. And obviously it's a function of t, so we're going to write of t. What is u prime of t? Well, u prime of t, you should hopefully know we're just using power rules, so don't get confused. Here we're differentiating, okay? Here, when we're doing u prime of t, we just use our regular power rule, okay? And we get, sorry, to the fourth, right? Subtract 1 from the exponent, all right? When we're doing reverse power rule is when it's different, and that's where you don't want to get confused. So this is 2 plus t to the -3, -7. Okay. So we want to get -12. So how are we going to do that? So we're going to write negative. Okay, we already have a 3 in here, sort of. So you could see there should already be a 3. So I want to get 12. So we're going to multiply by 4. So we have to divide by 4 on the outside. And now you should notice we have our u prime and we have our g of u, right? Choosing g of t to be equal to t to the -7. We get -1/4 of the antiderivative of t to the -7 dt composed with our inner function u, which we chose up here, okay? And this, of course, should hopefully be as easy as putting 2 and 2 together, right? -6, and then hopefully you know kind of how to do this antiderivative, right? We're gonna use Lewis power rule. I already dropped the number down, right? So it would become we're adding 1, so it would become -6. But of course, what are we gonna do? We're gonna compose it, so we're just gonna replace that with u of t. And if that's not clear, you can write out all the steps. Write this out, then compose it. But this becomes our new input for. So don't forget to add that plus c, and we're good, and we can move on to the next problem. So our next problem is sine q of x. Here is where you might get a bit stuck, and you might be thinking, what can I do? I mean, I only have one function. I don't know. So remember, here's where we have to do algebraic or trigonometric inequalities. Okay, so what are we gonna do? Uh, I would like to probably try this. I think this is a good idea because I know how to express sine squared of x as, well, just cosine squared. And this is just sine of x dx. And of course, I can write this down like this. So cosine squared of x times sine of x dx. All right, and I could definitely do this integral. It's this integral now that becomes the problem on the right. So here is where I might be thinking of doing reverse chain rule. So what would be our u? Well, I'm thinking if it's sine, then its derivative is cosine, but I don't have a cosine. I have a cosine squared, right? So what if I choose cosine? Then its derivative is negative sine. I already have a sine, so that's looking pretty good. I'm going to choose u of x to be cosine of x. Then the derivative of u is negative sine of x. So then this is just equal to negative cosine of x, right? That sounds pretty obvious. Plus, right, because we're taking out a minus, and I'll show you negative sine of x times cosine squared of x dx. All right, and this is our u prime. So this should be our g of u. So that means our g of x is just x squared, right? So we're going to get negative cosine of x plus the antiderivative of g of x, which is just the antiderivative of x squared dx, composed with our u of x, which we said was cosine of x, all right? So I'm getting a bit cramped up here, but negative cosine x. Okay, and what we're going to do is that we're going to say this is x cubed over 3, and composing it, we get cosine cubed over 3 plus c. Never forget that c. And our second to last problem, right? We're cutting through this, getting through this. Hopefully this isn't too long, right? So what is our u? We could try cosine of x, but we don't have a derivative anywhere in the numerator. So maybe sine of x. Oh yeah, we have a cosine of x, so we're good. So we can choose sine of x, right? Because we have a cosine of x in the numerator. So u prime of x is cosine of x. And notice if it was cosine squared, then we couldn't do it, right? We need only cosine of x. That way we can get cosine of x times x to the -3 composed with sine of x. Hopefully you see this and this are the same thing. Remember, become an expert at compositions. All right, and then from this, we can tell this guy's our u prime and this guy's our g of u. So that means our g of x has to be x to the -3. Oh, and I know how to do this, right? This is just reverse chain rule. I'm gonna write x to the negative 3 of x dx composed with our u of x sine of x, right? And hopefully you know how to do this. This is negative 1/2 times sine of x to the power of negative 2, right? Plus c, never forget that plus c. And our final problem is more of a challenge. So you can give it a shot. I'll zoom in so that you can kind of see what's going on because you might not see it. So I'll rewrite it here. So you might want to give it a shot. Remember all the tips I told you. If you need to manipulate algebraically before doing it, you want to try out some U's in your head, go ahead and do that. So I'm going to show you the solution now, and I'll show you my thought process. First, I noticed I can't really do anything, right? This is kind of a useless problem. But I noticed I have a 1 plus x squared here, and this is 1 plus x squared to the 3 halves, which is 1 plus x squared times 1 plus x squared to the 1 half. So I could factor out a 1 plus x squared. That looks like it can maybe do something, and if it doesn't work, then I can just erase my steps. So what I'm going to do is I'm going to write 1 plus x squared here to the 1 half, and I'm going to take this out of the square root. Now here, I just get 1, right, because it's a repeat. But here, remember how I was mentioning that this right here is 1 plus x squared times 1 plus x squared to the 1 half. So I'm just going to have 1 plus x squared to the 1 half left. Okay, and this all of this is dx. So now what? Well, if I let this be my u of x, I don't really have a 2x. I mean, I do. I could have this numerator, and then that works. But then what? Then I have 1 plus u 1 half of x, and I could probably do another u sub or maybe do something, but I don't like that, right? And remember, whenever you have 1 plus, we can always add 1 because the derivative is 0. So I personally think instead of choosing this to be our u, this is a more adequate u, um, right? I personally think instead of this inside, it should be this whole thing, and I'll show you why that makes sense. We're going to choose u of x to be 1 plus 1 plus x squared to the 1 half. Then u prime of x is, okay, this becomes 0. This is, oh, the derivative of square root. I know how to do that off the top of my head. Power rule, right? I'm going to drop the exponent down. I'm going to what? Put this here. I'm going to subtract the exponent by 1. Chain rule, remember, times 2x, right? So this just becomes that times x. But wait, this is in the denominator, so we have a negative power here. And this is x. So we have this. This, even though you might not notice, this is u prime. And this, we can just create our g of x. So we're going to write this as x times 1 plus x squared to the negative 1 half times, what do we have? Well, this whole thing, I'm just going to write with a negative exponent, right? So that it becomes more obvious what's going on. Okay, and this we said was our u prime. So this must be our g of u. So our inside function we said was u, and what's being applied to it is x to the negative 1. So that's our g of x. Our g of x is x to the negative 1. So using reverse chain rule, we get this dx. Um, no, sorry, to the negative 1 half. I forgot that little detail here. I guess I left it out. Yeah, we split the root here. It should be 1 half, so negative 1 half. Sorry about that. But that doesn't change your substitution, so this should be x to the negative 1 half. That way, now we know how to, do this integral, which should be now apparent using our z of x. We said with x to the negative 1 half dx. Composed it with our u of x, 1 plus 1 plus x squared to the 1 half. Of course, if you know your chain rule, which I'm hoping you do, reverse chain rule now, we have done enough problems that you should become quite familiar with the whole ordeal, at least to some extent. That's the hope. We should get 2, we're composing it 1 plus 1 plus x squared to the 1 half, all of that to the 1 half, because wherever we see an x, we replace it with this inner function. And never forget to write the plus c, because it makes the difference. Hopefully this video helped you understand reverse chain rule. You can let me know how you think I could have improved. If you want me to explain a bit more, if you want me to answer problems, I can definitely do that. So just keep these things in mind, right, when doing a reverse chain rule. You shouldn't get too hard problems, but I always think it's better to practice with harder problems. That way, the problems just seem easy, okay? So good luck reviewing chain rule, and I know you have this, all right?